We're joined by an expert to explore some foundational concepts in deep learning: embeddings, latent space, and representations. Welcome.
Thank you. Glad to be here.
Let's begin by clarifying some terminology often encountered in deep learning: embeddings, latent space, and representations. Could you briefly explain what these terms mean and how they differ?
Great question. While often used interchangeably, there are subtle differences. Embedding vectors are specific representations of data where similar items are close together in a continuous vector space. Latent vectors refer to intermediate representations of data within neural networks. Representations broadly encompass any encoded version of input data, including simple methods like one-hot encodings or embeddings themselves.
Let's dive a bit deeper. What exactly is an embedding, and why is it important?
Embedding transforms high-dimensional data, such as sparse one-hot encoded categorical variables, or even dense data like images, into lower-dimensional, dense vectors. These vectors maintain meaningful relationships, meaning similar items will be close to each other, which is vital for tasks like recommendation systems or natural language processing.
Could you give us a concrete example of how embeddings are created?
Certainly, take categorical data, such as colors, red, green, blue. Using one-hot encoding, red becomes 100, green is 010, and blue is 001. An embedding layer in a neural network then maps these sparse vectors into dense, continuous embedding vectors, capturing deeper relationships or semantics beyond simple categorical distinctions.
Can embeddings also be generated from images?
Yes, images, convolutional neural networks often produce embeddings. Typically, the output from a convolutional neural network's second-to-last layer acts as an embedding. These embeddings encapsulate essential features that help in image recognition, clustering, or visualization.
Interesting. Now, what exactly do we mean by latent space?
Latent space usually refers to the space where embedding vectors reside. Think of latent space as a compressed, intermediate representation of the original data. For example, in an autoencoder, a neural network trained to reconstruct input data, the central bottleneck layer compresses data into a smaller latent representation. Similar items, such as pictures of cats, typically cluster closely in this latent space.
And how does the concept of representation fit in here?
A representation is a more general term. It includes embeddings and latent vectors, but also simpler forms like one-hot encodings or embeddings themselves. Essentially, a representation captures critical information from the original data, making it useful for further processing and analysis.
To wrap up, could you mention examples of neural network layers useful for producing embeddings?
Sure. For instance, in architectures like AlexNet, the fully connected layers, especially the second-to-last layer, are commonly used to produce useful embeddings. These embeddings become powerful representations useful in downstream tasks.
And finally, what are some examples of representations that aren't embeddings?
Simple one-hot encoded vectors, raw pixel intensities from images, or directly numeric values without semantic structure are representations but typically not considered embeddings, as they don't inherently encode meaningful distances or relationships.
Thank you so much for clarifying these concepts.
You're welcome. Happy to help.